morning students. Today I am going to discuss irrational number, real number and their decimal expansion, terminating and non-terminating decimal expansion, representation of root 5 on the number line. So I am going to discuss first irrational number. Numbers which cannot be represented in the form P upon Q, where Q is not equal to 0 and PQ are integers. Example: root 2, root 3, root 17, pi, etc. are the example of irrational numbers. Here, normally a student asks about pi. Its value is 22/7. So sometimes a student confused. It is in the form of P upon Q. After all, it is known as irrational number. Why? Because this is an approximate value. So we call it irrational number. We call it irrational number. Now, I would like to discuss real number and their decimal expansion. For this, we take an example 7/8. We divide 7 by 8. So 8 0 0, 7. Then put one decimal, and for this we put 1 0. Then 8 8 64. 10 minus 4, 6. Then put 1 0. 8 7 56. 10 minus 6, 4. Then put 1 0. 8 5 40. So here we see that remainder is 0. This decimal expansion ends after finite steps. So such types of decimal expansion is known as terminating decimal expansion. Now I am going to discuss non-terminating decimal expansion. For this I have taken one example 1/3. So divide 1/3. 1 is less than 3. So 0 times 3 0 0. Subtract 1 minus 0 1. Now put a decimal, and for one decimal we put 0. Now 3 times 3 3 9. Subtract 10 minus 9 1. Again you put 0 from your side, and 3 3 9. 10 minus 9 1. Again put 1 0. 3 3 9. 10 minus 9 1. So we say that remainder is 1. It is repeating after certain steps. It is non-ending process. It will be divided 3 times endlessly. So such types of decimal expansion is known as non-terminating. Non-terminating, repeating decimal expansion. Now we take another example, 1 by 7. So divide 1 by 7. So 0 times 0, 1 decimal, for 1 decimal 0, 7 1 ja 7, then 1 0, 7 4 ja 28, subtract 8 minus 8, 2, 1 0, 10 2 ja 14, 10 minus 4, 6, 1 0, 7 8 ja 56, 10 minus 6, 4. So put 1 0, 7 5 ja 35, 10 minus 5, 5. Put 1 0, 7 7 ja 49. Subtract 10 minus 9, 1. Put 1 0, 7 1 ja 7. So 10 minus 7 will give you 3. Then put 1 0 from your side and 7 4 ja 28. Subtract 10 minus 8, 2. Put 1 0, 7 2 ja 14. 10 minus 4, 6. So put 1 0 here. 7 8 ja 56. 10 minus 6, 4. Again put 1 0, 7 5 ja 35. 10 minus 5, 5. So what do we see here? We are getting a block of digits, repeating digits. 1 4 2 8 5 7. One block, then again 1 4 2 8 5, and if you go one time more, 7 7 ja 49. So 1 4 2 8 5 7. 1 4 2 8 5 7. So this is an example of non-terminating decimal expansion. Here 1 4 2 8 5 7, 1 4 2 8 5 7 is repeating. It is a block of repeating digits. So we call it non-terminating repeating, or you may say recurring. Decimal expansion of 1 by 7. So in these two decimal expansion, we saw the quotient as 0.333 and 0.142857, 142857. This can be written as 0.3 bar, and we write 0.142857 as like this. First question says, is 0 a rational number? Can you write it in the form P upon Q, where P and Q are integers and Q not equal to 0? Solution. Yes, 0 a rational number. Yes, 0 is a rational number. It can be written in the form P upon Q. So we can write 0 as 0 by 1. Because when we divide 0 by 1, we always get 0 as quotient. Here P equal to 0 and Q equal to 1, where P and Q are integer. Now moving on to next question. The question says find 6 rational numbers between 3 and 4. We have 3 equal to 3 into what we have done here. We have multiplied 3 by 7 by 7. Because 6 plus 1 gives 7, 6 plus 1 gives 7. And if you multiply 3 by 7, you will get 3. There will be no change in the number 3. So 3 into 7 by 7, 3 7 are 21 by 7. Now 4 equal to 4 into 6 plus 1 by 6 plus 1. So 4 into 7 by 7, that is 28 by 7. Now 21 is less than 22, 22 is less than 23, 23 is less than 24, 24 is less than 25, 25 is less than 26, 26 is less than 27, and 27 is less than 28. So 21 by 7 is less than 22 by 7, 22 by 7 is less than 23 by 7, 23 by 7 is less than 24 by 7, 24 by 7 is less than 25 by 7, 25 by 7 is less than 26 by 7, 26 by 7 is less than 27 by 7, and 27 by 7 is less than 28 by 7. Now we have to find 6 rational numbers between 3 and 4. So 3 is equivalent to 21 by 7, this number, and 4 is equivalent to 28 by 7, this number. So the number in between 21 by 7 and 28 by 7 is 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7, 27 by 7. Now you 6, 1, 2, 3, 4, 5, 6. So these 6 numbers are in between 3 and 4. Going to solve next question. Question number 3. Find 5 rational numbers between 3 by 5 and 4 by 5. So we have 3 by 5 equal to 3 by 5 into 5 plus 1, 5 plus 1. Why do we add 1? Here it is saying we have to find 5 rational numbers. So we will take next number. That is why I have added 1 in 5. So 5 plus 1 divided by 5 plus 1. So 3 by 5 into 6 by 6 equal to 6 3 are 18, 5 6 are 30. Now next is your 4 by 5. So 4 by 5 multiplied by 5 plus 1 by 5 plus 1. It will give you 4 by 5 into 6 by 6. So 6 4 ja 24 by 30. Now 18 is less than 19. 19 is less than by 20. Similarly, 20 is less than by 20 is less than 21. 21 is less than 22. 22 is less than 23. 23 is less than 24. In the denominator we are having 30. So divide it by 30. But 18 by 30 is equivalent to 3 by 5. And 24 by 30 is equivalent to 4 by 5. So the 5 rational numbers between 3 by 5 and 4 by 5 are 19 by 30, 20 by 30, 21 by 30, 22 by 30 and 23 by 30. Moving on to the next question, that is question number 4. State whether the following statements are true or false. Give some reasons for your answer. Every natural number is a whole number. So solution. Every natural number is a whole number. It is true. Reason. Whole number starts with 0. 0, 1, 2, 3, so on. And natural number starts with 1, 2, 3, so on. This is natural number. This is whole number. So every natural number is a whole number. This natural number falls in the set of whole number. So this is true. Now come to question number 2. Every integer is a whole number. False. Reason. We represent integer on the number line. 0, 1, 2, 3, so on. Then -1, -2, -3, so on. These are integers. Question says every integer is a whole number. Suppose this is integer and here is whole number. -2, we cannot find -2 in the whole number. We cannot find this -2 or -3 or -1 in the set of whole number. So this is false. Every integer is a whole number is false. Every integer is not a whole number. 1, 2, 3 natural number may be whole number, but -1, -2, -3 cannot be a whole number. So every integer is a whole number is false. Now third statement says every rational number is a whole number. So first we know what is rational number. Rational number is in the form of P upon Q. And whole number starts with 0, 1, 2, 3, so on. We take an example of rational number. Suppose this is 3 by 5. Suppose rational number 3 by 5. So every rational number is a whole number. 3 by 5 is not here in the set of whole number. In the set of whole number 0, 1, 2, 3. So 3 by 5 is not here. That is why this is false. Now we will solve question number 1. of exercise 1.2. Question number 1. State whether the following statements are true or false. Justify your answer. First question. Every irrational number is a real number. So first we know what is real number. Real number includes rational number, and irrational number. So, question says every irrational number is a real number. So, irrational number is the part of real number. So, it is true. Now, we will discuss part 2 of question number 1. Every point on the number line is of the form root m, where m is a natural number. This is false. Reason. To understand it, we first draw a number line. 0, 1, 2, 3, so on. Then minus 1, minus 2, minus 3, so on. This is a number line. Here we see natural number 1, 2, 3. But to the left we are seeing minus 1, minus 2, minus 3. This is negative number. But question says every point on the number line is of the form root m, where m is a natural number. But minus 1, minus 2, minus 3 are not natural numbers. So, every point cannot be represented in the form root m. That is why this is false. Now, we discuss question number 3. Every real number is an irrational number. It is false. Because real number consists of rational number and irrational number. Every real number is an irrational number is false.